Okay. Chapter 5, Straight Line Graphs. Let's get straight into it with Section 1, Gradient Max plus E. Find the gradient of the line through the points -2, 7 and 4, -5, and hence state its y-intercept. We apply the formula change in y over change in x to get the gradient. For change in y, -5 minus 7, which is -12. For change in x, 4 minus -2, which is 6. So -12 over 6 is -2. So the equation of the line is y equals -2x plus c. And then we use the point -4, 5 to find c, the y-intercept. So 5 equals -2 times -4 plus c. So 5 equals 8 plus c. So c must be -3. So the equation of the line is y equals -2x minus 3. The gradient is -2 and the y-intercept is -3. So you say to us, find the gradient of the line that passes through the points -2, 7 and 4, -5, and hence find its y-intercept. And we say to you, the gradient is -2 and the y-intercept is -3. Write 6x minus 3y plus 12 equals 0 in the form y equals mx plus c, and hence find y when x is equal to 5. So it's 6x minus 3y plus 12 equals 0, right? So we move the other two terms to the right-hand side. So minus 3y equals minus 6x minus 12. We turn everything positive for convenience. So 3y equals 6x plus 12. So y equals 2x plus 4. Y equals 2x plus 4. Now we let x equal 5. So y is 14. So you say to us, write the line 6x minus 3y equals 12 in the form y equals mx plus c, and hence find y when x is equal to 5. And we say y equals 2x plus 4, and hence y is 14 when x is 5. The line y equals mx plus 5 passes through 3, negative 1. Find m, and hence find the x-intercept. Okay, so we're going to substitute 3 for x and negative 1 for y. So negative 1 equals 3m plus 5. Negative 1 is 3m plus 5. Oh, so negative 6 is 3m. So m is negative 2. So the equation of the line is y equals negative 2x plus 5. So what about the y-intercept? Well, set y equal to 0 and then solve for x. Just a second, I think I dropped something. No, I think that's fine. Y is equal to 2x add 5. Alright, so that means that the x-intercept is negative 5 over 2. So you say to us that the line y equals mx add 5 passes through the point 3, negative 1, and you ask us to find the gradient m and the x-intercept. And we say the gradient m is 2 and the x-intercept is negative 5 over 2. So we apply the gradient formula, change in y over change in x. So 3k minus k all over 5 minus 1. So 2k over 4. And that's supposedly equal to 2. K over 4 is equal to 2. Well, 2k is equal to 8. So k is equal to 4. K is equal to 4. The equation of the line is y equals 2x plus c. We can now use the point 1, 4 to find out what c is, the y-intercept. So 4 equals 2 plus c. So c must be 2 as well. So you say to us that a line passes through 1, k and 5, 3k and has a gradient of 2. And you ask us to find k and hence find the y-intercept of that line. And we say that k is 4 and the y-intercept is 2. The line of gradient negative 2/3 passes through the point 3, 4, and it crosses the axes at intercepts A and B. What is the sum of A and B? Okay, so the equation of the line is y equals negative 2/3 x plus c. We sub x equals 3 and y equals 4. So 4 is equal to negative 2/3 of 3 plus c. So 4 equals negative 2 plus c. So c must be 6. X plus 6. Negative 6 equals negative 2/3 of x. So multiply 6 by 3 over 2. And we get that the y-intercept is 9. Or rather, that the x-intercept is 9. The x-intercept is 9. So the y-intercept is 6 and the x-intercept is 9, and their sum is 15. So you say to us that a line with a gradient of negative 2/3 passes through the point 3, 4. And you ask us to find the sum of the intercepts of the line with their axes. And we say the answer is 15. Okay, section 2 is finding equations of straight lines. Find the equation of the line that passes through negative 1, 2 and 3, 10, and hence find the value of y when x is equal to 10. Alright, so we're going to use the change in y over the change in x formula. So 10 minus 2 over 3 minus negative 1 is 8 over 4, so 2. So the gradient is 2. So y equals 2x plus c. We're going to use 3, 10 now. So 10 equals 2 times 3 plus c, so c must be 4. So the equation of the line is y equals 2x plus 4. But what you want is you want the value of y when x is equal to 10. So it must be 24. So you say to us that a line passes through negative 1, 2 and 3, 10, and then you ask us for the value of y when x is equal to 10, and we say 24. A line through 2, negative 3 has a gradient of 4. What is the equation of that line? And find out where it crosses the x-axis. So, the equation of the line so far is y equals 4x plus c. We sub in x equals 2 and y equals negative 3. So negative 3 is equal to negative 3 is equal to 4 times 2 plus c. So c must be negative 11. So the line has the equation y equals 4x minus 11. Now what's the x-intercept? It must be 11 over 4. 11 over 4. So you say to us that a line passes through 2, -3 and has a gradient of 4, and you ask us for its x-intercept, and we say 11/4. Find the equation of the line that passes through the points 5, 1 and -1, 4, and put it in the form ax plus by plus c equals 0, where a, b and c are integer coefficients. Okay. So it passes through 5, 1 and -1, 4, right? So we're going to use the gradient formula, which is change in y over change in x. So 4 minus 1 over -1 minus 5. So 3 over -6. So -1/2. So y equals -1/2 plus y equals -1/2 x plus c. Now we use 5, 1. Y equals -5/2 plus c, rather. 4 equals -5/2 plus c. So c must be 4 plus 5/2, which is 6.5. So y equals -5/2 plus 6.5. I'm going to multiply everything by 2. So 2y equals -5x plus 13. So 5x plus 2y minus 13 equals 0. So you say to us that a line passes through 5, 1 and -1, 4. And you ask us to find the equation of that line in the form ax plus by plus c equals 0 with integer coefficients. And we say 5x plus 2y minus 13 equals 0. The points 0, 5, 2, k, and 6, 17 are collinear. Find the gradient of the line connecting them and the value of k. All right. So for the gradient of the line, we're going to use the first and last points mentioned, which is 0, 5 and 6, 17. And we're going to use the change in y over change in x gradient formula. So 17 minus 5 over 6 minus 0. So that would be 12 over 6, which is 2. So the gradient of the line connecting them is 2. Now, it must be the case that k minus 5 over 2 minus 0 is equal to 2. So k minus 5 must be equal to 4. So k must be 9. So you say to us, a line passes through 0, 5, 2, k and 6, 17, and these points are collinear. And you ask us to find the gradient of that line and the value of k, and we say the gradient is 2 and the value of k is 9. Find the equation of the line that passes through negative 2, 9 with a gradient of negative 3, and hence find its intersection with the line y equals x at 1. Yes, that's right. Find the equation of the line that passes through the point negative 2, 9 with a gradient of negative 3, and hence find its point of intersection with the line y equals x plus 1. The equation of the line is y equals negative 3x plus c. We use the point negative 2, 9. So 9 equals 6 plus c, so c must be 3. So the equation of the line is y equals negative 3x plus 3. Y equals negative 3x plus 3. Okay, so now find out where it intersects with y equals x plus 1. So set them equal to each other. Negative 3x plus 3 equals x plus 1. So 4x is equal to 2. So x is equal to a half. And y is equal to 1 and a half. So a half and 1 and a half. So you say to us that a line passes through negative 2, 9 with a gradient of negative 3, and you ask us to find the equation of that line and to find the point of intersection with the line y equals x at 1. And we say the equation of the line is y equals negative 3x plus 3, and the intersection with y equals x at 1 is 1 half, comma, 1 and a half. Alright, section 3 is parallel and perpendicular lines. Find the equation of the line that passes through the point 2, 5 and is parallel to the line 3x at y is equal to 4. And also find out where it crosses the y-axis. All right. So, first of all, the line 3x at y is equals 4 has a gradient of -3. So y equals -3x plus y equals -3x plus c. Now let's use 2, 5. So 5 equals -6 plus c. So c must be 11. Oh, that's it. Y equals -3x plus 11 and c is 11. So you say to us that a line passes through 2, 5 and it's parallel to 3x at y equals 4. And you ask us to find the equation of the line and to find the y-intercept. And we say y equals -3x plus 11 and the y-intercept is 11. Find the equation of the line that is perpendicular to the line which passes through 1, 2 and 5, 10, and which itself passes through 5, 10. Okay, the gradient of the line connecting 1, 2 and 5, 10 is 2. So the gradient of the line perpendicular to that must be -1/2. So y equals -1/2 x plus c, and we're going to use now 5, 10. So 10 equals -2.5 plus c. So c must be 12.5. So you ask us what line is perpendicular to the line which passes through 1, 2 and 5, 10 and itself passes through 5, 10. And we say the line y equals -2.5x plus 12.5. The lines y equals k take 1 times x plus 3 and 2y at 8x equals 5 are perpendicular, find the value of k. So we're going to find the gradient of the second line. So if 2y at 8x is equal to 5, then 2y equals negative 8x plus 5. So the gradient of it must be negative 8 over 2, which is negative 4. And hence, for the other line, the gradient must be 1/4. 1/4. But if k minus 1 is equal to 1/4, then k itself must be 5 over 4. So you say to us that the pair of lines y equals k take 1x at 3 and 2y at 8x equals 5 are perpendicular and ask us to find the value of k, and we say k is 5 over 4. Find the equation of the perpendicular bisector of the 2 points A, which is negative 1, 3, and B, which is 5, 7, and put it in the form ax plus by equals c. Or rather, ax plus b... No, I got it right. Ax plus by equals c. I'm going to presume that they mean integer a, b, and c, but that's fine. Okay. So, gradient formula, change in y over change in x. So we do 7 minus 3 over 5 minus negative 1, which is 4 over 6, which is 2/3. So y equals 2/3 of x plus c. And now we're going to use the point 5, 7. So 7 equals 10 over 3 plus c. Or 7 equals 3 1/3 plus c. So c must be 3 2/3. 3 2/3. But anyway, they don't want it in this format. They don't want to hear y equals 2/3 x plus 3 2/3. What do they want to hear? They want to hear it in the form ax plus by equals c. So what you're going to do is you're going to multiply everything by 3. Okay, so that means 3y equals 2x plus 11. So minus 2x plus 3y equals 11. So you say to us that a line passes through the pair of points A, which is negative 1, 3, and B, which is 5,7, and you ask us to put the line in the format of ax plus by equals c. And we say to you, minus 2x plus 3y equals 11. The line perpendicular to y equals 2x minus 3, passing through the point 6, 4, meets the line y equals 2x minus 3 at the point P. Find the coordinates of P. Okay, so it's perpendicular to y equals 2x minus 3. So its gradient is negative a half. So we know that it's y equals negative a half x plus c, and it passes through 6, 4. So 4 equals negative 3 plus c. So c is 7. So now we have y equals negative a half x plus 7. Now, let's set them equal to each other. So negative a half x plus 7 equals 2x minus 3. Are you sure it's this? Well, it seems like it's negative 2.5x plus 7. Yeah, that looks about right. It looks right. All right. So 2.5x. It feels wrong though. Well, just try again. The line perpendicular to y equals 2x minus 3, passing through the point 6, 4, meets the line y equals 2x minus 3 at the point P. Find the coordinates of P. As it's perpendicular to y equals 2x minus 3, its gradient must be negative a half. So its equation must be y equals negative a half x plus c. We now use the point 6, 4, so 4 equals negative 3 plus c. So c must be 7. So the equation of the line is y equals negative a half x plus 7. Now set them equal to each other. Negative a half x plus 7 equals 2x minus 3. So 2.5x, 2.5x equals 10, right? Yeah, 2.5x equals 10. So that's fine. So x is just simply 4. And if x is 4, then y is 5. 4, 5. So you say to us that the line y equals 2x minus 3 passes through the point 6, 4, and, right, no, beg your pardon, you say that a line perpendicular to the line y equals 2x minus 3 passes through the point 6, 4 and meets the line y equals 2x minus 3 at the point P, and to find the coordinates of P. And we say to you 4, 5. Now section 4 is length, midpoint, and area in coordinate geometry. For A, which is 1, 2, and B, which is 7, 10, find the length of the line segment AB and the midpoint of the line segment AB. Well, if the endpoints are 1, 2 and 7, 10, then just apply the Pythagorean theorem. Okay, so that would be the change in x squared plus the change in y squared, all square rooted. And in this case, it's pretty obvious that it's 10. As for the midpoint, you just have to find the midpoint of the x coordinates and then the midpoint of the y coordinates. The midpoint of 1 and 7 is 4, and the midpoint of 2 and 10 is 6. So it's 4, 6. So you say to us, or rather, you ask us to find the length of the line segment connecting the points A, 1, 2, and B, 7, 10, and to find the midpoint. And we say to you the length of the line segment is 10, and their midpoint is 4, 6. The line 3x at 4y equals 24 meets the axes at the point. The line, it's hard to get it right. The line 3x at 4y equals 24 meets the axes at points A and B. Find the length of the line segment AB and find the area of the triangle OAB. Okay. Well, I guess first we'll just find out what A and B are and let them be the intersections with the x-axis and the y-axis respectively. Okay? So, 4y equals negative 3x plus 24. So y equals negative 3/4 x plus 6. So the y-intercept, or b, is 6. Now what about the x-intercept? Well, for the x-intercept, I mean, we can really just use the original form, which says 3x at 4y is equal to 24, and we can just substitute x equals 0 and y equals 0. That's actually far better. Okay. Wait, are you sure? Are you sure it's 3x at 4y equals 24? Oh, yes. Okay, I am. All right. So I have to begin again. You say that the line 3x at 4y equals 24 meets the axes at the points A and B, and then you ask us to find the length of the line segment AB and to find the area of the triangle OAB. Okay. If we let x equal 0, then we find where it meets the y-axis. So it meets the y-axis at 6. And if we let y equal 0, we find out where it crosses the x-axis. So it meets the x-axis at 8. So this is the 6, 8, 10 triangle. So the length of the line segment AB is 10. And its area must be 24. So you say to us that 3x at 4 equals 24 meets the axes at the points A and B, and you ask us for the length of the line segment AB and the area of the triangle OAB, and we say that the length is 10 and the area is 24. Okay, for the points A and B, where A is negative 2, 1 and B is 4, 9, you ask us to find the length of the line segment which goes from the origin to the midpoint of AB in surd form. So what we're going to do is we're just going to find the midpoint of A and B. So it's the midpoint of the x coordinates and then the midpoint of the y coordinates. So the x coordinate is 1 and the y coordinate is 5. So their midpoint is 1, 5. And the distance from the origin is root 26. Root 26. So you say to us that there are 2 points A and B whose coordinates are negative 2, 1 and 4, 9. And you ask us to find the distance from the origin to their midpoint in surd form, and we say to you root 26. Okay, a triangle has vertices 0, 0, 4, 3, and 8, 0. Find its perimeter and area. Very well. I'm going to find the length of the three sides one by one. From the origin to 4, 3, that's obviously just simply 5. From the origin to 8, 0, that's just 8. Now, from 4, 3 to 8, 0, well, that's going to be, that will be 5 as well, won't it? Okay, so its perimeter is going to be 18. Now, what about its area? What about its area? Well, this is an isosceles triangle, isn't it? No, it's not. Can you not see what I've just drawn on the picture? I can see it, so don't talk to me like that. All right, calculate. That's not correct, is it? That's getting a different result. Okay. Yes, I'm pretty sure it is. You know that. Yes, I do. Okay, so the area is 20. So you say to us that a triangle has vertices 0, 0, 4, 3, and 8, 0, and you ask us for the perimeter and the area, and we say 18 and 20. Not much longer now. A is 2, 3, and B is 8, 11. Given that B is the midpoint of AC, find C and then find the length AC. Okay, so to get from 2, 3 to 8, 11, you add 6 and then you add 8. So we follow those instructions and apply that to point B. So that would be 14,19. 14,19. But then you ask for the length of AC. So we're just going to find the length of AB and then double it. Sounds good. So we know that the length of AB is 10. So that length there is 20. So 14,19 and the length is 20. Right, the last section is modelling with straight lines. A taxi charges £3 and £2 per mile. A certain journey costs £29. Find the length of the journey and the cost of a journey that's twice as long. Alright, well if the journey in question, the first journey, costs £29, then we take away the initial cost of £3 to bring us down to £26, and then we divide by the cost per mile, which is £2, so we get 13. So it's a 13-mile journey. But for a 26-mile journey, you need to do 3 plus 2 times 26, which is 55. So you say to us that a taxi cab charges £3 plus £2 per mile for a journey, and a certain journey costs a certain journey costs £29, and then you ask us to find the length of that journey and the cost of a journey that's twice as long. And we say that the length of that journey is 13 miles, and for the one that's twice as long, it would cost £55. A candle is 30 centimeters initially and 18 centimeters after 4 hours of burning. Assuming linear burning, find the height of the candle after 7 hours of burning, and also when it extinguishes completely and when it's burned out. Okay, so it's burning at a rate of 3 centimeters per hour. So after 7 hours, what you do is you do 30 take away 7 times 3, meaning that the candle will be 9 centimeters tall. And how long will the candle last in its entirety? Well, if it's 3 centimeters per hour and it starts at 30 centimeters tall, the answer is 10 hours. You say to us the height of a candle is 30 centimeters initially, and after 4 hours of burning it's 18 centimeters tall. And assuming linear burning, find out its height after 7 hours and when it extinguishes completely. And we say to you 9 centimeters and 10 hours. Gym A charges £30 plus £4 per visit. Gym B just charges you £10 per visit. Find the number of visits when their cost of usage is equal and what that cost of usage actually is. Alright, so we can say n is the number of visits. So we say 30 plus 4n equals 10n. And so 6n is equal to 30. So n is equal to 5. So after 5 visits, their cost of usage is equal, and that cost of usage is £50. You say to us that Gym A charges £30 plus £4 per visit, and Gym B charges £10 per visit, and you ask us how many visits would be required to make the cost of usage equal, and how much would that cost of usage be, and we say 5 visits and the entire cost would be £50. A car worth £12,000 initially is worth £9,000 after 2 years. Assuming a linear depreciation rate, find out its worth after 5 years and when it's worthless entirely. Okay, so it's depreciating at a rate of £1,500 per year. So 1.5 times 5 is 7.5, and 12,000 takes 7,500 is 4,500. As for when it becomes entirely worthless, well, that's however many 1.5s fit into 12, and we know that the answer to that is 8. So you say to us that a car is worth £12,000 initially, and after 2 years it's worth £9,000, and assuming a linear depreciation rate, find its worth after 5 years and when the car becomes worthless entirely. And we say to you its worth after 5 years will be £4,500, and it will be entirely worthless after 8 years. Alright, the last one. A temperature of 20 degrees at 6 p.m. falls to 12 degrees, or rather, let's begin again. A temperature of 20 degrees Celsius at 6 p.m. falls to 12 degrees Celsius at 10 p.m. Assuming a linear rate of decrease, find out the temperature at midnight and when it becomes 0 degrees Celsius. Okay, so 4 hours have elapsed and it's decreased by 8 degrees Celsius during that time, so it's obviously decreasing at a rate of 2 degrees Celsius per hour. So at midnight, which is 2 hours ahead of 10 p.m., it will go down from 12 degrees Celsius to 8 degrees Celsius. And when will it become 0 degrees Celsius? Well, at 4 a.m. 4 a.m. So you say to us that a temperature is 20 degrees Celsius at 6 p.m. and 12 degrees Celsius at 10 p.m. and assuming a linear rate of decrease, find out the temperature at midnight and when it becomes 0 degrees Celsius. And we say to you its temperature at midnight will be 8 degrees Celsius and it will become 0 degrees Celsius at 4 a.m. All right. Wow, that was a long one.